Alright, so here we're going to look at a bit of an example of a dilution problem. So say I've got a solution of hydrochloric acid. Okay, we've got a 400 ml solution, and the concentration is 0.63 mole per liter. Okay, so that's what we're starting with. And what I want is I want to dilute this solution such that I have a new solution with a concentration of 0.21 mole per liter. Okay, I want to somehow turn this solution of 0.63 mole per liter into a solution of 0.21 mole per liter. Okay, so I'm going to do that by adding a volume of water. Okay, so starting with 400 mils, we're adding some water. The volume of the water we're adding is called change in V. We'll call that delta V, and we want to find delta V. Okay, that's what we want to do here. We want to find delta V. Okay, so the first thing that we're going to do, rather than use that, we know that we've got this formula C1V1 equals C2V2. We know I've got that tucked up our sleeve, okay, but what we want to do first, we're going to work through this logically, okay, and see how we can just do it by simple logic of the problem, okay. So what we want to do here, we've got 0.63 mole per liter, and we've got 400 mils. Let's find out the mole of HCl that we've got in this solution, okay. So the mole of HCl is equal to let's use a formula. It's equal to the molar concentration times the volume, 0.63 times 0.4. Okay. Now, this gives us 0.252 mole. Which should be times. Okay, and we know that the one key part about dilution questions is that this number stays the same, okay? This number is unchanged because all we're doing is adding water, okay? So the mole of hydrochloric acid in this solution is not getting changed. Okay, so what we want to do now is we want to create a solution with concentration of 0.21 moles per liter. Okay, so we know that we've got this general formula, C equals N over V. Okay, now what we do is we know the mole of hydrochloric acid, and we know the concentration that we want, 0.21 mole per liter. So let's find the volume that we need to make this solution. Okay, so we go volume is equal to mole of HCl over the concentration of HCl. Okay, so this is equal to 0.252, okay, as we worked out above. We know that we want it to be 0.21, so we put that at 0.21, okay, and that gives us 1.2 litres. Okay, so we know that the final volume, once we've added water, we know that the final volume needs to be 1.2 litres, okay? We have 1.2 litres of solution, and we have 0.252 moles of hydrochloric acid, then we're going to get a solution with concentration of 0.21 mole per liter, okay, and that is what we want. Okay, so this is the final volume, and so just to show you how this formula can apply to it, okay, so we want to find V2, so if we say that V2 equals C1 V1 over C2, 0.63 times 0.4 over 0.21. Okay, and what that gives us straight away is 1.2 litres. Okay, so we can use this formula and we get the same answer as if we just used our logic and figured out the mole of hydrochloric acid here, okay, and then the volume that we would need to make a solution of concentration 0.21 mole per liter, okay, which is what we've done here. Okay, so we can use either method. If we're feeling a bit tired, just plug this formula in. Otherwise, think through the logic and understand what's happening, okay, and see why we get the same answer here and here. Okay, so this is where we can often run into sort of cheap mistakes. Okay, so we figured out that the final volume after dilution needs to be 1.2 litres, okay, given that we've started with this solution, 0.63 mole per litre and 400 millilitres. Okay, but this is where the easy mistake comes. If we're asked how much water to add to this solution, okay, This is not the answer, okay? It's very easy for us to think, oh, okay, I've done all the calculations, this is the answer, okay? But that's not the case. This is this number here. 1.2 litres is the final volume, okay? And we're asked to find this number here, the change in volume. Okay, so if the final volume is 1.2 litres, okay, then this volume is going to equal 400 millilitres. So we'll call this, actually, instead of writing 400 millilitres, we'll keep all the units the same. We'll call it 0.4 litres plus change in volume. Okay, so therefore we know that the change in volume is going to equal 1.2 minus 0.4 equals 0.8 litres. Okay, so rather than putting in our final answer as 1.2 litres, let's look, that's the final volume. We want to find how much water we're adding, aka the change in volume. Okay, so if we start with 400 millilitres and we want to end up with 1200 millilitres or 1.2 litres, we're going to have to add 0.8 litres or 800 millilitres. Okay, that's our final answer, is 800 millilitres. Okay, so either of these will do, but the important thing is don't see the final volume and think, okay, that's my answer, okay? Because that is not the answer, okay? No, not there. Okay, we need to figure out how much water we need to add to the 400 mils we're starting with in order to get to a solution of 1.2 litres, okay? And so what we need to add here is 0.8 litres.